Hello everyone, good morning, good evening and good afternoon for everyone who is tuning in. On behalf of SBA Egypt Young Professionals, I would like to welcome you all to today's workshop. My name is Ahmed, fresh graduate petroleum engineer from Cairo University and a member of workshops and their trips committee at SBA Egypt YB. Before we start, I would like to remind you, please drop your questions in the chat box and please keep the chat box professional and ethical. Now please give a warm welcome to Engineer Ahmed Samy, who will be the instructor of today's Managed Pressure Drilling workshop. Engineer Ahmed Samy is currently an Managed Pressure Drilling at BGS Energy Services. He holds a Bachelor in Petroleum Engineering from Cairo University. He started his career with BGS Energy Services after completing BGS MPD school at Houston, Texas, where he acquired operational experiences and the technical background in managed pressure drilling. Also, he wrote 2 technical articles in 2019 for oil and gas newspaper about the importance of MPD to the oil and gas sector in Egypt and the advantages of MPD to the asset integrity. Also, Ahmed has been providing a series of lectures about MPD for students from various universities, for example, Cairo, British, Suez, and AOC universities in the past 2 years. And now, Engineer Ahmed, the mic is yours.
Thank you, Ahmed. First of all, I want to wish you all a happy new year. And before we start, we need to, before we go deep into the presentation, I need you all to know that today's presentation will be an introduction to the managed pressure drilling. And the agenda for today, just 1 second, the presentation is loading. Okay, so for today we are going to speak about the MPD concept, and it will be like an introduction to the Mbd Technologies for those who don't know anything about the MPD. And then we are going to speak about the MPD definitions and what is the common techniques in the market and how we are going to control the annular pressure. Then we are going to review the B&ID. Then we are going to speak about the MPD flow passes during drilling, during connections, if we got an influx. And finally, we are going to speak about when and why to use the MPD. So let's refresh our mind by speaking about the conventional operations. During drilling and when the pumps are on, the bottom hole pressure is equal to the hydrostatic pressure plus the annular friction pressure. So we have the bottom hole pressure almost constant. But during connection and when the pumps is off, we lose the annular friction pressure. So because there's no circulation. So a drop in the bottom hole pressure happens. And if this drop is below the bore pressure, an influx may occur. But in MPD operations and during drilling, yes, we have the bottom hole pressure equal the hydrostatic pressure plus the annular friction pressure, but we have additionally new term, which is the surface back pressure. Okay, so this term, what happens when we turn off the pumps and are going to do a connection? So the equation will be like the bottom hole pressure equal to the hydrostatic pressure plus the surface back pressure. And in that case, we increase the surface back pressure so that we can have almost near constant bottom hole pressure. So the bottom hole pressure is the same during drilling and connection, or almost the same. Okay, so let's try to make it clear on this graph. If you have the pressure versus the depths, okay, and this is our formation. We are drilling now, and we have the mud weight, statically mud weight, okay, and we are drilling conventionally. So if you are drilling now and the pumps are on, so the bottom hole pressure will increase due to the annular frictional pressure, and it will be this line. But if we stop drilling and are going to do a connection and we turn it off the pump, so maybe the bottom hole pressure can go down here less than the bore pressure. In that case, we may have an influx. But using the MPD, okay, this is the mud weight, and we have the annular friction plus the pressure, the surface back pressures that we do using our choke MPD chokes, okay? So we can keep the bottom hole pressure almost constant, even if we if we stop drilling and we are going to do connection, yes, we raise the surface back pressure, and we also can keep it, the bottom hole pressure, keep it constant. Okay, so now, what is the MPD? MPD is the managed pressure drilling. And accordingly to the International Association of Drilling Contractors, the definition is MPD is an adaptive drilling process that we use to precisely control the annular pressure profile. Okay, and the objective is to avoid the continuous influx. And this is so important for us to avoid continuous influx. So that this means that, yes, influx may occur, but this will be safely contained using the MPD. Okay, so we said that the definition is to precisely control the annular pressure. So, before we speak about how to control the pressure, we need to know that we have 4 MBD techniques that we can use to control the 4 MBD techniques in general. First of all is the constant bottom hole pressure, okay, which reduce the non-productive time and enable us to drill when the bore and fracture pressure are almost near to each other and we have a narrow pressure window. Second technique is the pressurized mud cap drilling, which enables us to drill in the extreme loss situations. The third technique is the dual gradient, which usually used in the deep water drilling. And finally is the return flow drilling or continuous circulation system, which is mainly related to the HSE to reduce the risk to the personnel and the environmental from the drilling fluids. Okay, so today's presentation will be only about the constant bottom hole pressure, about this technique. Okay, so we said that the definition of MPD is to control the annular pressure. So how we are going to control the annular pressure? We need to use both the engineering and use equipment. Okay, so for the engineering, we should design our hydraulics. So what we need to design, or what we need to know or to have, we need to calculate the MASP, which is the maximum allowable annular surface pressure. We need to know the annular friction pressure. And finally, we need to calculate the bottom hole pressure. Okay, so we have the bore pressure and the fracture gradient. So we can use the fracture gradient to get the pressure, the fracture pressure. And the fracture pressure is equal to the hydrostatic pressure plus the MASP, which is the maximum allowable annular surface pressure that we shouldn't exceed, because if we exceeded this value, we are going to frac the formation. Okay, so we have the fracture gradient, we get the fracture pressure, we calculated the hydrostatic pressure, so the mass will be the fracture pressure minus to the hydrostatic pressure. So number one, we already know the mass. Second, we need to calculate the annular friction pressure. So there's an equation we typically follow for calculating this pressure, which is equal to 1.4327 multiplied by 10 to the power negative 7. We multiply this to the mud weight in ppg and multiplies by the true vertical depth in feet, then annular velocity divided by the hole diameter minus the drill pipe diameter. Okay, and if you need to know how to calculate the annular velocity, you have this equation, which is 24.5 multiplied the circulation rate divided by the hole diameter minus the pipe diameter. Okay, so now we know the mass and we know the annular friction pressure. It's time to calculate the bottom hole pressure. So we have two conditions. The first is the static condition. Static means the pumps are off, no drilling. So in that case, the bottom hole pressure will equal to the hydrostatic pressure plus the surface pressure. And in the dynamic conditions, the bottom hole pressure will equal to the hydrostatic pressure, and we add the annular friction, then we add the surface pressure. All of us know that hydrostatic pressure plus the annular friction, okay, is called the ECD, equivalent circulating density. Okay, so we discussed about the engineering way. Let's talk about the equipment we need to have on site so that we can control the annular pressure. We have the RCD, which stands for rotating control device. Second, we have a choke manifold, which helps us to apply the pressure, and the flow meter, Coriolis flow meter, and the MPD control system, which we have on the doghouse so that we can control our equipment. Okay, so how we put this equipment together? If we check this diagram, first the mud is pumped from the mud bits, okay, up to the standby, then it goes down the top drive, and then goes down to the drill string from the drill bit, then it comes up back via the annulus, and it goes out from the RCD. The RCD is used to isolate the well bore. Okay, after we got it from this side, it goes from the flow spool pipe and is connected directly to the Mbd manifold, which do its process, and then it's sent it back to the, either if we have MGS, it's sent it to the MGS. If we need to send it back to the mud beds and the mud shakers, we do it. Okay, so let's speak or make it clear on the B and the ID. Here we have our RCD, which is inserted above the annular BOB, okay? Then it's connected down from here to the MPD choke manifold, then to the Coriolis flow meter, and then we can send it directly to the shell shaker or the MGS. It depends on the operation. So this is how we connect our equipment. Also, we have the back pressure pump, which the cement pump can be used, the rig pump can be used, that we can use for doing the back pressure. Before we go on, I need to know if you have any questions. So Ahmed from SPE, can you help us in this?
Engineer Ahmed, you can continue. There is no questions till now. There is a question who asked to repeat the ECD concept again.
Okay, anyone have any other questions? Just let me know all the questions.
No. Just the ECD again, please. And another one. Another one ask why we need managed pressure drilling exactly.
Okay, we are going to speak about this point at the end of the presentation. There's a slide speak especially about when and why to use the MPD.
Okay, and another one want you to repeat the circulation cycle again.
Okay, on the B and ID, the one who asked about the circulation cycle, you need to know it about the B on the B and ID, right?
I think that, yes.
Okay, I will discuss it. Okay, so first, someone asked about the ECD. Okay, so let me go back to the ECD slide. Okay, so the ECD stands to equivalent circulating density, which means that it's the hydrostatic pressure plus the annular friction pressure. Okay, and if you need to calculate it, here is simply the calculation is the mud weight plus the annular friction that we calculated from this equation, and we divided by 0.052 and we multiplied by the true vertical depths. I hope this answers your question.
I think that.
Uh,
I think that's clear.
What is the RCD? The RCD is rotating control device, and I will show you a video when we finish the presentation about how it works.
Another question is L is measured depth or true vertical depth in annular pressure loss calculations?
The true vertical depth.
A question you said, fully understand that we can compensate losing of the friction pressure by trapping more BSI, but what about other parameters such as like surge and swab and thermal effect?
Losing of the friction. Okay, this question we can answer it at the end of the presentation when we finish all the information.
Oh, I think we can continue.
Okay. Okay, so let's keep going. Okay, so for those who were asking about the circulation, you will discuss now the every condition we have, the drilling condition, the during connection, how's the flow path during if we are going to circulate an influx, and also during the conventional drilling. Okay, so first of all, let's speak about the drilling flow path using the managed pressure drilling. So usually we have the rig pumps which start the circulating and it goes out from the standby, it goes down. This is so normal, but the return, we take it from the RCD, and instead of sending it to the rig choke, like in the conventional operation, no, we send it to the, like, follow the arrow, okay? We move directly to the Mbd choke manifold. And if it's okay, nothing happened, we can complete going on to the Coriolis flow meter. We measure the flow, and then it's okay, we can complete sending it to the chill shaker if there's no gas, and send it directly to the chill shaker and the MGS if we need, and so on, and complete the circulation process, okay? This is during using the MPD, which means that the flow passes by the MPD choke manifold. And usually when we use this to avoid anything to happen, any downhole event, okay? Because if something happened, if an influx occur, then we are already have our MPD choke manifold that we can close the choke, apply back pressure to the well, and we keep the bottom hole pressure. Okay. During connections, what happened during the connection? During the connection, we start using the back pressure pump, which may be the cement pump. If the rig have 3 pumps or whatever, we can use and to apply a back pressure to the flow. The return flow that is coming from here, follow like this, then it has a pressure coming from the back pressure pump, which allow the circulation to start going through the Mbd choke manifold, through the flow meter, and keep going up to the chill shaker, the MGS, and then send it back again to the mud tanks. So we keep it like this. Keep it here. And this area has a back pressure from the back pressure pump. Okay, if we have an influx, what should we do using the MPD? So if we are drilling conventionally and suddenly we have an influx happened, okay, so like same as drilling using MPD, it entered to the MPD choke, then to the flow meter, but instead of sending it back to the chill shaker, no, we send it from this way back to the MGS, first of all, to separate the gas, the MGS normal operation, then we send it back to the mud tanks. Okay, so in case of the conventional drilling and conventional well control, what typically happened? We are drilling, then we put it through the rig choke, and then from the rig choke again back to the NGS. So the purpose from showing you the flow passes is just to understand how it works on the rig side. Okay, just want you to, I will show you first a video, okay, that can make the things more clear, then we will go back and complete our presentation.
The preloaded seal cartridge is retrieved from the deck, made up, and run in whole using the speed-fixed cheese marking. The locking dots lock the seal cartridge in place when the seal cartridge is landed. Fluids for gradient chamber control and seal lubrication are injected into the seal cartridge, and a pacing system integrity is checked and controlled on the control system display. The pressure below the PC is equalized prior to opening the annular. The range will penetrate colors that have a red flat into it. The Cmwist pressure control device system consists of the pressure control device with seal cartridge and pore protector, a pressure distribution skid, a control container, lubrication tanks, A visual display. Head drill tips. The patented sealing solutions represent a new and reliable technology for the MPD industry. Instead of one or two rotating elements, as in most of the RCDs, the Cmwist system uses 4 non-rotating seals, stacked in a seal cartridge. The well pressure is evenly distributed over the seals by means of gradient chambers. There are pressure sensors below each seal for control and monitoring purposes. The condition of each seal is continuously monitored and held. The gradient chamber pressures are displayed on the control system and automatically adjusted depending on well pressure. During drilling, the operator monitors real-time seal status, allowing immediate seal leakage and detection. The operator will continuously monitor leakage on the HMO system and can plan for seal cartridge replacement when convenient. Due to the multi-seal configuration, drilling can continue even in the event of seal failure. This excellent redundancy in BCD provides valuable and secure predictable information. The Cmwist PCD system represents a game-changing technology for the managed pressure drilling industry, providing predictability through real-time condition monitoring of the seal status, early wear detection, and redundancy through the multiple seal barrier. In addition, the running of the seal unload cartridge is fast, safe, and efficient. Welcome to the future of pressure control heads.
So, gents, before we go on, I need to know if anyone have any question on this video. Okay, I can repeat it again because this video is important so that it can make the definition of the RCD clear.
Engineer Ahmed, I think the problem was the sound of the video. The sound of the video wasn't good. So can you share a link for the video?
Okay, but let me try to play it again. Okay, and if this time it works, okay. If not, I'm going to send it to you. Okay.
Okay, Engineer Ahmed.
The Cmwist pressure control device, the PCD 5000, is a device that caps and seals return mud flow in managed pressure and underbalanced drilling operations for fixed installations. The control device uses the Cmwist's unique and patented sealing solution, which provides a safe, predictable, and efficient sealing technology using non-rotating sealing elements. The PCD is a multi-seal barrier with seal status monitoring in managed pressure drilling operations. A bore protector is installed when seals are not required. The protector has a through bore of 13 5/8 inch. The bore protector is run and retrieved with a fixed J-slot running tool installed in the drill pipe. When the running tool has engaged the J-slot, the locking dogs are released and the bore protector can be retrieved. The bore protector is retrieved and can be racked back in the derrick. The preloaded seal cartridge is retrieved from the derrick, made up and run in whole using the same fixed J-slot running tool. The locking dogs lock the seal cartridge in place when the seal cartridge has landed. Fluids for gradient chamber control and seal lubrication are injected into the seal cartridge, and the PCD system integrity is checked and controlled on the control system display. The pressure below the PCD is equalized prior to opening the annular. The running tool and drill collars can now be racked back in the derrick. The Cmwist pressure control device system consists of the pressure control device with seal cartridge and bore protector, a pressure distribution skid, a control container, lubrication tanks, a control system display, and drain tanks. The patented sealing solutions represent a new and reliable technology for the MPD industry. Instead of one or two rotating elements, as in most of the RCDs, the Cmwist system uses 4 non-rotating seals, stacked in a seal cartridge. The well pressure is evenly distributed over the seals by means of gradient chambers. There are pressure sensors below each seal for control and monitoring purposes. The condition of each seal is continuously monitored and logged. The gradient chamber pressures are displayed on the control system and automatically adjusted depending on well pressure. During drilling, the operator monitors real-time seal status, allowing immediate seal leakage and wear detection. The operator will identify any sign of wear and leakage on the HMI system and can plan for seal cartridge replacement when convenient. Due to the multi-seal configuration, drilling can continue even in the event of seal failure. This excellent redundancy of the PCD provides valuable and secure predictability for the operation. The Cmwist PCD system represents a game-changing technology for the managed pressure drilling industry, providing predictability through real-time condition monitoring of the seal status, early wear detection and redundancy through the multiple seal barrier. In addition, the running of the seal element cartridge is fast, safe, and efficient. Welcome to the future of pressure control heads.
Hey gents, please let me know if the video was good and you hear it well, or you need me to explain it. Or if you have any questions, please go on and ask. Proceed with ask.
I think there is no questions for the video, but you can explain the main parts of the video.
Okay, someone need me to explain it? Just let me know which part you need me to explain it.
I think explain the main part of the video, the main objective of the video.
Okay. Okay, we have questions, Ahmed, here, so it's good. Let's wait like 1 minute until we have all the questions, and I will start explaining by answering the questions.
Okay, the first question, BCD has 4 sail chambers.
Okay.
The second one, how pressure is distributed on the gradient chambers.
Okay.
For the BCD, the question was why it has 4.
Why it has 4? Okay. Go on, I will explain when you finish all the questions.
The third one, what is the benefit of the G tool?
Okay.
Pressure distribution skid function, please.
Okay, so I will share video with no sound and I will start to explain on it. Okay, I hope you can hear me, okay? I will start explaining the video. Okay, first, for this who asked about the G slot tool, it's used to remove the backer or remove the rubber from the BCD. First, the BCD, it's same like the RCD, which is the rotating control device. It has sealing cartridge, okay, or rubbers. Here it is, 1, 2, 3, 4. This rubbers is used to isolate the well bore, okay, and the function is that it can rotate, it allows the drill pipe to rotate inside. Okay, so if something happened and there's a failure with the rubber, we are going to need to replace this cartridge. So how we are going to replace it? First, we open this remote dogs, and then we insert the G slot tool, and we use it to pick up or retrieve the backer from the RCD, as you can see now. the gradient chamber. This chamber is like a lubricant for the rubber, and it has two functions. First of all, it's a lubricant, okay, to lubricate between the pipe and the rubber, and second, to apply pressure to the rubber so it keep it tight. Okay, this is the G slot tool. Okay, if we need to replace, it goes down, and then we open the dogs and we retrieve the buckers up. Okay, also for this who asked about the gradient chamber, I will explain this part. Okay, the gradient chamber, it helps us to distribute the pressure on the rubbers. Okay, so we use the fluid, we can apply 75% from the wellhead pressure to this rubber and decrease it when we go up. Also, it can help us to monitor the rubber states, because if a leak happened or a failure happened to the rubber, then you will find on the screen down, like the pressure will go down because it lost the pressure on the rubber. If you see when the tool joint comes from, apply more back pressure, so the pressure goes up until we finish. Okay. I hope this covers your questions. Okay, before we keep going, I need to reply to a question. Okay, I was waiting until I show you the video, I guess. Ali asked about friction trapping, PSI. No. Oh, Amr. Amr was asking that we can compensate. He said, I'm fully understand that we can compensate losing of the friction pressure by trapping more PSI, but what about other parameters such as the surge and the swab? And he also asked about the thermal effect. Okay, Amr, I was waiting until you see the video, because as we all know that the swab effect, it's a term that it happens from moving the pipe too quickly when you are pulling out of the hole, and moving it up, and the swab effect may induce a gain or influx. And the surge is the opposite if we are going down too quickly. So usually and typically there's an MPD operator that's on the rig floor 24/7, and he's seated all the time with the driller, and he's making sure that the driller is moving the pipe as slow as possible so that we avoid the swab and the surge. Okay, and what if we have a swab and surge effect? In that case, we have the back pressure pump that we use to circulate across the top of the well, so that we can compensate the swab and the surge pressure effect. And also before going to the operation, we use the hydraulic model so that we can check for the effect of the surge and the swab. I hope this covers your question. And also in the hydraulic model, we can check for the thermal effect. But since this is an introduction to MPD, so I don't want to go deep in these details because it's only to give you an introduction about the concept of MPD, since it's not so familiar. I hope this covers your question, Amr.
Engineer Ahmed, Amr asked again, so you are limiting the tripping speed?
Yes, I'm trying to control it as much as we can to slow it down.
And another one asking, can you explain more on the swab and surge effect?
Okay, I will explain again my answer, okay? First, what is the swab effect or what is the surge effect? The swab effect, it's moving the pipe too quickly when we are pulling out of the hole. Moving this up, do something called by swab effect, and this may induce a gain or influx. Okay, the surge effect is the opposite to the swab. It's if you are going down too quickly. This may cause losses. Of course, so this is the answer for the swab and the surge. Amr was asking about the effect of swab and surge on the MPD or how we can control it. So I'm telling him that we usually, the MPD operator he's with the driller 24/7. He trying to make sure that we move the pipes as slow as possible so that we can avoid the swab and surge effect. But in case there's swab or surge, we have the back pressure pump. We use this back pressure pump to circulate across the top of the well so that we can compensate the pressure that happened from the swab or surge. I hope this answers your question. And again, if you still this is not clear to you, we can have a chat when we finish if you want to go deep into deep information, because it's only introduction and I don't want the rest of the guys to lose concentration. Okay?
Engineer Ahmed, another question. What if limiting speed not accepted by the client?
Okay, so we have the back pressure pump. We use the back pressure pump to apply pressure across the top of the well so that we can compensate the surge effect.
Okay, and again, I think it's the same question, but limiting tripping speed plus the time consumed of the connection, I can see MDB will waste a lot of time. Are you agree?
Okay, so Amr, I will leave my email when we finish the presentation because the rest of the guys are asking us to go on, okay, since it's only introduction. But I will send you my email now in the chat, okay, and we can keep talking after we finish. Thank you, Amr. Okay, let's go on. So now we spoke about the MPD concept for the constant bottom hole pressure. We know now that we have 4 MPD techniques. We're speaking only about the constant bottom hole pressure. We know the equipment, we know what we need for the engineering, and we have checked the flow process. So now it's time for when and why to use the MPD. So when to use the MPD, mainly we use it to drill to the target, which means that we use to drill the undrillable, which is a well with a tight pore or fracture pressure gradient, a narrow window, or if we have a vaggy fractured carbonates, or there's high in situ stresses, or if there is a rapid change in the pore pressure or abnormal pressure or something. So in that case, we prefer to use the MPD, because using an MPD, it reduces the non-productive time if something happened and we need to deal with. And since we reduce the MPT, we save cost. Okay, so also we can use it to increase the ROB since we are drilling near balance, okay, conditions, which have like we decrease the chip hole defect, so we can increase the ROB. We can reduce the number of loose kick scenarios that may happen or may occur. Reduce the time spent to control conventionally with the well control events. And also one of the best advantage from the MPD is that we can detect the kick earlier. And we all know that the earlier we detect the kick, the better we can keep drilling and control it. Also to differentiate between the kick and the ballooning, and reduce the pressure cycle from fatigue that is related from the borehole instability, and reduce the open hole exposure time, and definitely reduce mud cost. And we can also set casing deepers, optimize the number of casing streams. All of this help us to save cost, reduce non-productive time. And finally, to improve the safety. You can now trip safely. You have closed the well, it's not open hole, and the H2S hazard from at the rig floor is now eliminated, and we can drill the high pressure, high temperature wells safely. So this was an introduction to the MPD concept and technology. I know it's not deep, but just I want you all now to have like a clear image about the MPD. So if you have questions, you can go on.
So, Engineer Ahmed, thank you for this informative session. For anyone of the attendees or anyone who has a question, please don't hesitate to drop it now. Someone asked difference between underbalance drilling and managed pressure drilling.
Okay.
Another question, any difference between kick and ballooning?
Yeah, I'm waiting till we have all the questions so that we can answer it one time.
The third one, how can managed pressure drilling service the drilling high pressure, high temperature wells?
Okay.
Request from one attendees, Mahmoud, please send us some more references on the managed pressure drilling topic. How does MPD optimize number of casing strings? Another question, how there is not a backflow when applying back pressure on connection?
Okay.
Can you please explain the main steps of the planning and designing of an MPD project? Another question, what is your view regarding applying managed pressure drilling in ERD wells? Case of narrow window. And finally, how managed pressure drilling reduces mud costs?
Okay, any more questions? Okay, let's start with answering the question for the difference between the UBD, the under balance drilling, and the MPD, the managed pressure drilling. Mainly, the UBD, the target for the bottom hole pressure is to be below than the reservoir pressure or below than the bore pressure. But in MPD, no, the target is to be near the bore pressure, maybe a little equal to or a little more above the bore pressure. So this is the main difference without going into deep details. Another question was how can MPD serves the drilling for the high pressure, high temperature wells?
Yes, engineer.
Yeah. So I will not say all the answers, but I will tell you something that may happen from the high temperature wells. We are drilling a high temperature well. You have like too much failure in the mud pumps rubbers, so too many stops. So maybe you can have an influx, and in that case, MPD is preferred because if something happens, a sudden failure or something, you can circulate through the managed pressure drilling, and you can mitigate all the risk from these sudden stops. This who needs reference? Okay, I will send you reference. We'll make sure to send you a reference via email. Okay. How can MPD serve drilling the high pressure, high temperature wells? I will go back to my slide and I will show you how this can help us. Look, here, imagine if we don't have MPD and we are drilling conventionally, okay? And this is our mud weight. And with the friction, the annular friction pressure, it's okay while drilling. But if something happened or during connection, and if we stopped in that area, we are going to have an influx. So in that case, we need, if we're going to drill conventionally, we have to set a casing. But in case of MPD, no, we are going to apply back pressure, surface back pressure, so we can keep going even during connection. Another question.
Another question was how does managed pressure drilling optimize number of casing strings?
Yeah, we just answered this.
How there is not a backflow when applying back pressure on connection?
Okay, let me go to the slide. Okay, so during connection, we circulate through the RCD, have the return goes to the MPD manifold, but we have our back pressure pump that apply pressure here in this point. So it has a back pressure on the return flow, okay? And in same time, we are circulating this, we are circulating from the back pressure pump through the MPD manifold. So we do like a closed loop here that apply back pressure on this side, which by the way keeps the pressure at the bottom hole while connection.
So it's just a equalization?
Yes, applying back pressure by closed loop.
Okay. The next question, can you please explain the many steps of planning and designing of an MPD project?
Yes, we can, but I can send it to you with the reference, because first you review the data, you check what is the problem we have, we select the mud we are going to use, then we start the hydraulic simulation and start selecting the equipment, and then doing the risk assessment, the hazard process, and so on. So I can send you the with the reference all the steps.
Okay, Engineer Ahmed, that's great. The next question, what's your view regarding applying managed pressure drilling in ERD wells, case of narrow window?
In case of narrow window, we just discussed same as the question for the casing strengths. You have a narrow window, so you need to compensate. You are afraid if you are drilling with, for example, like conventionally, you have the mud weight of 15 ppg. Okay, so with in conventional drilling, the ECD will be like 15.3, for example. But when we are using MPD, we can have, yes, 15 ppg mud, but we can make the ECD immediately to 16.5 or something.
Okay. How managed pressure drilling reduces mud costs?
Okay, let's go to this slide. Okay, so first of all, it reduced the non-productive time, okay, and improve the safety. All of this save the cost. How? By increasing the rate of penetration. It reduces the numbers that you stop to deal with the loss or kick scenario that may happen, okay, like the time you spend dealing with the well control event, and if it avoid having like blow down or something, so we can manage the kick as early as possible. It help us to differentiate between the kick and the ballooning, which we may have a ballooning, but we think that it's a kick, so we can stop and try to work as a well control, and it's okay, it's ballooning or something. That's on.
So Engineer Ahmed, the next one. What are the challenges that you can face while using MPD?
Mainly failing rubber failure.
On the RCD?
Yes, mainly. This is like so critical. If you have like sudden failure for the rubber, and this is something not good. But as you see in the video, now we can predict for the rubber failure. Also, yeah, we all know that typically the rubber have like lifetime. So if we are drilling, we know from the lifetime, but if we are if we are talking about abrasive well or something, and maybe sudden failure happened to the rubber, but now it's solved because the technology, now we can predict the failure of the rubber as you see in the video.
Okay, Engineer Ahmed. It's from the pressure, the back pressure that the rubber behind the rubber, or what?
Say again the question because I was reading our question.
Is the failure from the rubber itself mechanically, or the pressure behind the rubber?
No, wear from the wear. Wear
Okay.
that happens due to the friction from rotating the drill pipe inside. Another question which was so good from Amr that you are saying that we have 4 rubbers. Are these going to fail? No, not the 4 rubbers are going to fail, of course. But it depends on the company policy or the client policy. Maybe the client say if you have one, the client say like I want you to insert only 2 rubbers. I don't want the quad barriers. I only need double barrier. And in case of failure, you will check on the screen that there's a rubber failed or something, and the client will refuse to go on with only one barrier. So in that case, you will need to stop, go a trip up until you can change the rubber. And this may happen, and you just finish the trip. And when you reach the TD and start drilling, you discover that the rubber is failed. So you wasted time going up again.
Okay, Engineer Ahmed, the next one, how can we manage running casing with Mbd technology?
Okay, this is like a good question, but we need to discuss it separately because it's advanced.
Okay. Kick and the ballooning again. The difference between kick and the ballooning.
Okay. The ballooning, it's like when drilling is near the fracture pressure and we have the bumps on, the formation may take some mud, okay? And when we turn off the bumps, the formation kick back the fluid that it have or give us back the fluid. This is the ballooning. But to differentiate between the kick and the ballooning, that the kick will continue to have flow out, okay? But the ballooning, it will stop after a little bit. Not only this, but also the pressure and temperature.
Okay, Engineer Ahmed, which pumps are used for the back pressure circuit?
It depends. We can use the back pressure pump, the cement pump. We can have our own back pressure pump. We can use the rig pump. It depends. If the pump, for example, if the rig have 3 pumps or something, we use 2 and we have the third one, we can use it. If there's a cement pump, we can use it. If not, we can have our own back pressure pump. It's okay.
Okay. Can you have a quick look on MPD equipment, please? I think.
Okay. Here's the equipment. It's the RCD, rotating control device, the choke manifold, which help us to reduce the flow, apply back pressure. If we are not going to use the cement pump or the back pressure pump, we can use the choke. The Coriolis flow meter that measures the flow and help us to indicate if there's a kick or something. And the control system.
Can you change the rubber under pressure?
Yes, we can change the rubber under pressure. But in that case, we divert the flow through the rig choke. And we have to close the BOB.
Okay. So any other questions? So another one, drilling with MPD create a slightly overbalanced wellbore pressure versus the formation pressure.
You mean the BHP? Yes, it's maybe near or a little bit above. So we call it like near constant bottom hole pressure.
Another one asking about pressure distribution skid in BCD.
Yes, it helps us to distribute the pressure among the 4 rubbers we have. We can control if we need to distribute it equally, if we need to like apply more pressure on one rubber than another one. Also, it helps us to detect the failure of the rubber because now we have a pressure, so we know if a sudden failure happens, we can check it on the screen.
Another one, installation of RCD above BOB needs more space under substructure in land rigs, or there is a special stack.
Yeah, exactly. It's need like it need certain distance between the substructure and from the BOB to the substructure.
So what are the challenges you have while switching from rig pumps to cement pump while connection?
Let's go back to the, I will show you. So during connection, we have no challenges. It's just we have cooperation with the driller and we start the pump, the back pressure pump. We turn off the valves to avoid any return to the rig choke or something, and we divert the flow to the choke manifold, and we circulate, make a closed loop again. Then the back pressure pump, then this create a back pressure to the flow. So definitely no challenges, just the driller cooperation.
So any other questions? Please don't hesitate to ask. So Engineer Ahmed, it seems that there is no other questions. So for you, if you would like to say something before ending.
Yes, so just share again with you guys. If anyone need anything, I will share my contact information. Please feel free to contact me via email or cell phone anytime if you need any help. Thank you so much for your time.
Well, thank you, Engineer Ahmed, for this informative session again. And thank you for all attendees for their question and their attendance.